Hi, let's continue the evaluation test or decision matrix for disease diagnostics. Now, we want to discuss about predictive values. So, what are predictive values? First of all, let's start with this decision matrix 2 by 2. So, last time we discussed about sensitivity and specificity. So, what are those? So, that is, when you have a disease, if the test result positive, higher sensitivity. When you do not have a disease and the test results will likely to give you negative, so true negative, that's the specificity. Now, let's consider what are another ways of studying this. Okay, so those are the another aspects that what if those who have a positive test result and who are curious about whether someone really has a disease or not, or I got already negative result, how much I trust that I do not have a disease. So that's about predictive values. Does it make sense? Okay, so let's consider an example. Hey, I got a call from my mom that my mom underwent a test for, let's say, cancer diagnostics. And she told me that, oh, I got negative value. Oh, I'm so happy. So when I hear that, so as a scientist, an educated scientist, what should you consider? So given that the test negative result, how much should I trust the result that my mom really do not have a cancer? Or how much of there is a possibility that there may be missing the disease, so-called false negative, the potential for this. So that's another question. And on the other hand, hey, I went to a place and I went back and I got test of coronavirus. And I realized I got positive result. So that's so surprising, right? So given that I got positive result, then I should ask myself, like, do I really get the coronavirus or not? So given I've got this positive result, how much of I should trust that I will likely to have the real disease or not? That is the question we are asking, okay? So which is definition-wise, it's not too difficult. So let's see. So the purpose of the predictive value is to evaluate the usefulness of a positive or negative test result, which is very close to what we feel that, hey, I've got a positive test result, then my question, have I really get the disease? Or I have got negative test result, how much should I be, feel safe or feel free from the result from the disease for the negative. So the definition is positive predictive value, or PPV, is a probability that a positive test correctly identifies an individual who actually have the disease. Okay, so PPV should be defined as the amount of true positive out of all the positive. Does it make sense? Because given positive, we are curious how much are truly positive. Likewise, negative predictive value is out of negative value test result, how much truly I am really negative, no disease. Okay, so the probability that the negative test correctly identifies an individual who do not really have the disease. Does it make sense? I have this table which kind of summarizes so far what we have discussed. So test as a positive and negative, a disease as present or absent. So A, B, C, D, sensitivity is defined by when we have a disease, so A plus C, how much is truly positive, okay? Specificity is when I do not have a disease, how much of I am really negative. Okay, why predictive values are positive predictive out of given the test value of positive, how much I really do have the disease. While negative predictive value is I've got already negative, how much should I be feel safe that I really having absence of disease. So these four are something very important. But what I want to point out is, in fact, sensitivity and specificity is kind of the value you can have a test setting or bioinstrumentation having that threshold giving positive and negative. So it belongs to the instrument or the test. While, interestingly, this positive predictive value and negative predictive value, in fact, that can vary in different situations, especially disease prevalence, meaning that out of this population, how much of the portion really get the disease, this proportion or prevalence will affect the positive and negative predictive value. So we'll discuss about this further. So the effect of disease prevalence on predictive values. The best way is to having an example. Let's say there is a village which has a population of 2,000 people and a diagnostic test. Usually tests are pretty good, like 90% sensitive and 90% specific. In this case, the positive and negative predictive values will vary when the prevalence of the disease is varied. Let's see what does this mean with an example. So here, let's say in this case, it does, to some it's all 2,000 population. However, the disease have 1,000, no disease 1,000. So this is a prevalence of 50%. In that case, while the other cases, disease are a little rare, that disease is 200 out of 2,000, so 10% have disease, the other 90% do not have a disease. So the prevalence will be a 10%. In these two different cases, let's calculate the predictive values. So if there's a lot of disease, like half of the population has this disease, then if you calculate PPV, meaning that, hey, I got a positive, how much am I really have the disease is almost 90%. Hey, you've got sure you almost have the disease. And what about negative predictive value? So this is also out of negative. I have no disease is 900, which means almost 90% are negative, which means, oh, you can feel safe that you've got negative result, that you will not have the disease. So that's one, but on the other hand, prevalence of 10%, so it's relatively kind of rare in this case. Then what's the PPV is out of positive, you have the disease is almost the same. So PPV is a 50%, which means when disease is a 10% prevalence, even if you've got test result as positive, the chance of you really getting the disease is only about 50%. What about negative? If disease is rare and prevalence is low, then negative predictive values out of this is almost 99%. So very low prevalence. If you got negative result, you can be almost for sure that you won't have the disease. Does it make sense? So these left panel as a high prevalence, then PPV and NPV will be similar to sensitivity and specificity in this case, because this sensitivity and specificity is like 90% and 90%. However, low prevalence case, the positive predictive value decreases. So when rare case of disease, even if you've got positive result, like you don't have to worry that much until you've got further tests, okay? Does it make sense? And if you got negative, for sure you don't have the disease. Okay, so like this is kind of similar, but I have three types of prevalence of 10%, let's say like a diabetes in case, and let's say we have an instrument having sensitivity of 99%, which means if you have a disease, 99% will catch. So you won't miss that disease much. And specificity is 90%, which is when you do not have a disease, yeah, you are likely to having negative result 90% of the case. So what are the PPV value? So if disease prevalence is 10% in this case, negative predictive is almost 100. Positive prevalence is, if you calculate it, out of this positive disease prevalence is 53%. So let's say like diabetes, we know that 10% of populations are diabetes, and you've got test and you're positive, but don't worry too much. Only you, about 53% of chance you will actually have the diabetes. So second one, I'm going to skip for the time, but let's think about prevalence of very low, like 0.1% of population got the disease. For example, like HIV, which is very low in South Korea. So let's say I took the test of HIV test, and oh my gosh, I got positive HIV result for this first test. So how much should I be worried about this? Okay, so in this case, like high sensitivity and specificity test, what's my positive predictive value, which is out of this sum divided by disease present, which is only about 1%. So even if I got HIV positive in this country, let's say HIV prevalence is only 0.1%, then don't worry too much. Even if you got positive, the positive predictive value is only 1%. Only 1% of chance you actually has HIV. So don't worry about much. But if you got negative, almost 100% sure. So does it make sense? So with this, I made a homework for you. So this is created by me, that using this decision matrix or the parameters we are given, assuming that sensitivity and specificities are constant, then how can you find out the relationships between sensitivity, specificity, and a parameter as a prevalence? See, prevalence should be between 0 to 1. Then I want you to express true positive, false positive, true negative, false negative in terms of function of sensitivity, specificity, and prevalence, and all means like all this sum. And also I want you to consider about positive and negative predictive values in terms of sensitivity, specificity, and disease prevalence. And the third is the question that what would happen about your predictive values if prevalence is very low or high? How does this affect the cost of your test? Okay, so you can spend some time, and here's the answer for you. And one thing you'll realize is having different values of sensitivity and specificity, I plot positive predictive value and negative predictive values. Okay, thank you for your attention.